Okay, well, thank you very much. Thank you again, as Ruben's saying, for staying for this session. My apologies. So I've got terribly bright lights in my eyes. I can't even see if there's anyone in the audience, you know. All I can tell, if you clap or you shout or you throw rocks or something, then I get to kind of see whether you're still here. The last day of the conference always tends to be tough, you know, especially after the afternoon, especially after lunch. Lots of people have to leave, you know, they have to go back to work or they have flights to catch and things like that. So I hope there's at least a reasonable audience here still able to stay until the end. Okay, so I work for GridGain, and GridGain is a startup company based in Foster City, California. And about 7 months ago, they came to me and said, we'd like to offer you a job. And they said, you're going to talk about open source and we're going to pay you. And I thought, great, I'll take it. You know, how many jobs can you find in the world these days where someone is happy to pay you and you just go out and talk about open source? You're not there to sell the technology, you're not there to do marketing, there's no kind of targets that you have to meet, and it's all about awareness and generating interest in Apache Ignite. Okay, so that's my role. I caused a little bit of trouble for the AV guys. Hopefully we'll be okay, so we'll see. Okay, so let's have a look. All right, so in terms of the presentation structure, I'll keep it fairly simple, okay? And also, I'll try to keep it reasonably sort of not too technical, okay? But I do have a demo which I'd like to show you. There is a saying in English, you know, Murphy's Law, anything that can go wrong will go wrong at the worst possible time. Fingers crossed it'll work okay. I have tested it on my laptop, does work okay. Okay, so just to show you something that's actually working. Demos are always risky, especially for live presentations, and you can be left very embarrassed and wishing you'd never done it, but okay, we'll give it a go. So in terms of the structure, a little bit about Apache Ignite, and then talk very briefly about Hadoop acceleration. And I guess the majority of you are probably more interested in Spark. Okay, that's the hot technology today, and seems to be what's replacing Hadoop in a lot of enterprises today. And even those organizations that have never used Hadoop, they are going straight to Spark. Okay, so that's the way things are. If you attended the Spark Summit a few weeks back in Dublin, I mean, phenomenal interest there again. Huge amount of presence, and the worldwide community, certainly for Spark, is just growing and growing. And so Ignite is a kind of a complementary technology. Sometimes people ask, I'm using Spark, why would I use Ignite? That's the wrong question, okay? It's a question of how the two can be used together. And I'll give you a little bit of an example, some Scala code. Don't be too afraid, okay? It's very simple code. We'll walk through it and I'll show you what's going on. And then we'll try and do a couple of demos there. And again, my time is sort of limited. I've only got sort of 23 minutes left, so there's a fair amount to cover, and we'll try and get through that fairly quickly. Okay, so what is Ignite then? So Ignite, in one slide, this is the kind of a high-level overview on the right-hand side there. So it's a memory-centric platform, okay? So its origins, where it came from, where GridGain developed it originally, is as an in-memory data grid, okay? It's a key value store. That's where it came from. And it's mature enough that, a few years ago, they donated it to the Apache Software Foundation. So on the Apache website, you can find it as Ignite, Apache Ignite. Very active development, okay? As with a lot of the Apache software projects, you're very welcome to participate, sign up for the dev list. There's a great sort of landing page. You can download the binaries, you can look at the source, you can build from source, many things that are possible. Plenty of information as well about users of this technology out there. A few things that they focused on over the past year or so is this notion of strong consistency, okay? So it gives you a strongly consistent view, as you might expect with something like a relational database system. It supports ACID transactions, for example. High availability, so the two kind of main selling points is scale and performance. So the ability to really expand and grow your cluster elastically as you need additional resources, and then shrink it again as you don't need those resources. This is a great sort of selling point. Comes with SQL. SQL, whether you like it or you hate it, it is the lingua franca. It's the intergalactic data speak, used very widely for a lot of systems today. Obviously comes from the relational world, but even if you look at the NoSQL guys today, they are adding SQL capabilities as well. Immense amounts of skills and tools are out there on the market, and it makes sense to support it. I mean, it's simply absurd to think that you wouldn't want to support it because of the amount of traction that there is behind the SQL standard. So key value I mentioned already in processing APIs. We'll look at a little bit of those as well. So as I said, two main things it's designed for are performance and scale. Data source agnostic, it's written in Java, however, it supports .NET and C++, and you can use a kind of a binary format that allows you to read and write objects that you've created amongst these three formats very easily. So you may have one production team, for example, working in Java, another one working in .NET, a third team working in C++. They can collaborate and work on the same set of objects that you're storing within this in-memory cluster. Fully fledged compute engine, durable storage. So originally, as I mentioned, it comes from this kind of in-memory data grid background, but they've added persistence capabilities. So you can save the state of data to disk. And the way it works is that all of your data is saved to disk. Some of it is cached now, okay? And as it needs more data, that can be paged in automatically for you. HTAP is the kind of focus, so both OLAP and OLTP type of applications, fully ACID transactions across memory and disk, and I know what you're probably thinking. You're thinking, hang on a minute, in cluster computing, how can you guarantee this type of thing, in terms of ACID transactions across your entire sort of range of machines that you have? Well, it's configurable, okay? The nature of life is such that in distributed environments, which are hard to build and hard to design anyway, you kind of accept certain guarantees, and you're willing to make certain sacrifices, and therefore, even there's a kind of a realization that you can't do this fully transactional and fully consistent across an entire cluster, okay? So there are some parameters that you can configure and change to give yourself a little bit of flexibility in this space. In-memory SQL support, which is great because once you've got stuff in memory, you can just run at memory speeds, joins. I know these are the most expensive operation in a relational system, but you can just work at relational, these memory speeds, working on this sort of relational data, having to do these joins across tables as well. As with everybody else, of course, there's machine learning support, but it's very early at the moment. So there is matrix, both dense and dense algebra support at the moment. So things like k-means and other types of machine learning capabilities being added gradually over time. And I think expect maturity of these towards the end of the year. There'll be a whole load of other things that they're adding. Future plans for things like deep learning, TensorFlow, and I think even MATLAB support is on the cards at some point. The community is kind of growing. Still relatively small compared to some of the other Apache projects, but it's building up over time. Okay, quickly then, let's have a look at Hadoop acceleration. So what's the key thing that we're trying to offer here? There is something called the Ignite file system, IDFS, okay? So this is an in-memory file system. It provides APIs that allow you to substitute HDFS out, and you can use IDFS, okay? So then you're working just at memory speeds. There's a couple of other things that you get as well, and because of the nature of the time that we have today, I've left a couple of the slides out. Those will be included in the full set that you'll be able to download, and you can have a look at that in a little bit more detail later on. So things like replacing, the job tracker, those kind of things that make your life easier, if you like, because Ignite can do a lot of the tracking for you. It's a hash map, okay, a distributed hash map. You apply an algorithm, you know exactly where your data are. There's no need for some of these other sort of components from the Hadoop world that you would otherwise need to use. Okay, so here's a kind of a graphic on the right-hand side where you can see that this IGFS is being used across these different nodes that are running some types of processing. All of the HDFS APIs are implemented, and it can transparently plug into both Hadoop and Spark deployments, okay? So the Spark is the more interesting thing, which we're going to get onto very, very shortly. So this is a distributed in-memory file system, okay? So, and as I said, can be act as a direct replacement for HDFS. All of the APIs are supported, so you get that memory boost that it provides without all the sort of baggage, if you like, that you get of having to work with HDFS and disk-based systems, okay? Now, the thing is, today, of course, memory is relatively cheap. You know, you can add terabytes of memory fairly inexpensively. And even hard disks, of course, are very, very cheap as well. And if historically you go back in time and look at things like SQL, well, they were designed in an era where memory was kind of tight, you know, and you went for disk-based optimizations, and you had to do that because of the relative cost of you know, the adding memory in those days. Well, today, some of those roadblocks have gone away, and you know, it's a lot better to be able to use memory for many of these applications. Okay, so we'll touch on some of these issues as well that we talked about Hadoop as well. So for Spark acceleration, then, one of the sort of capabilities that we have available is this notion of being able to share state across these Spark jobs. And the demo I'll show you a little bit later, very simple, but it sort of proves a point, okay? So it shows how this can really work. So avoids the necessity of having to write these RDDs to disk and then having to read them again later on, okay? So as you know, RDDs are kind of immutable. What they've done with Ignite is effectively they've put a wrapper around a cache, all right? So an Ignite cache is just, think of it a little bit like a relational table, okay? Just something that, or a collection, just something that's stored in memory. You can access that directly, and simply putting a wrapper around it to make it behave like an RDD is the solution that they've come up with. And again, in terms of the support, well, all of the native Spark API is supported. All of the native Spark transformations are supported as well. That really gives you sort of phenomenal sort of performance boost. Now, you're thinking to yourself, hang on a minute, you know, RDDs again. We're being told by the likes of Databricks and others that we shouldn't really be using these as developers. They're too low level, right? The world is kind of moving to data frames, data sets, and that kind of thing. That's true. But the thing is, this still provides a very sort of capable level of, you know, in terms of development and the ability to access things at low level. It's very useful in certain situations. Data frame support is on the way, okay? So the early development is already out there. You can have a look. If you sign up to the dev list, you can download the code, try it for yourselves. And I think that is going to, again, mature over the coming months. So, as I said, this is really just a view. It's a wrapper around an Ignite cache. Okay. So the way that we can work with this, and I'll just show you a couple of snippets of code, and again, in the interest of time, I've got about 13 minutes left, okay? So I want to kind of move on and show you a little bit of sort of a demo to see how this actually works in reality. So we've got this Ignite context, okay? Very similar to the idea of a Spark context. And we can either create it from scratch, we have this thing called Ignite configuration, or we just point it to some file that we've created previously, an XML configuration file. In the examples that I'm going to show you in terms of the running code, I'm actually going to use a predefined XML configuration file. It's actually provided as part of the download that you can get from the Apache website. Again, you can poke around, have a look at that in your own time, and be able to sort of check that out and see what it's actually doing. There's a couple of other options that we have available. So we have the ability to do shared deployments or embedded deployments, okay? And I'll get onto those in a moment as well. So very quickly then, in terms of how we can use these two approaches, well, there we've got a little bit of code, okay? So create the Ignite context based on the Spark context, and then either we do it like this, we say new Ignite configuration, or we simply point to some configuration file that we've previously created, and that's all we need to do. So the Ignite RDD, implementation of Spark RDD, representing a live view of an Ignite cache. Okay, so the key difference here is that, as you know, RDDs in the Spark world tend to be immutable. You can't change them. However, because of the way that this is implemented, it is mutable. Okay, it's the reverse. Any changes that go into this cache, they are visible immediately to everybody else, okay, depending on how you've set this up, whether it's on a per application basis, whether it's on a job basis, or if it's global, okay? So this is how they've implemented this. The other thing is that if you've got some specific partitioning information about your data, all of that information is available to the Spark executor as well. And lastly, this point about affinity information, kind of co-location of data, other things like this that are very, very useful in certain applications. That information, again, is available to Spark as well. So one of the scenarios that you might think about in terms of co-location, for example, is say you've got, if you remember a couple of years ago that New York suffered from this big hurricane. You have the population of New York, you could have them all stored, co-located with the city itself. If you want to send a weather alert to all the people that live in that particular city, you know exactly where the data reside. You can send out SMS messages to them directly without having to be able to scan your entire cluster, finding these people, and then being able to send that message out. So there are some useful cases where if you know the kind of processing that you're going to be doing in advance, this co-location idea becomes very, very useful, stops all this network traffic that you might have to do otherwise. And then part of what we're trying to achieve with this kind of distributed environment is we want to move the processing to the data rather than shifting the data around across the cluster. Okay, so I mentioned that Ignite works at the sort of key value pair level. Okay, so this is the implementation that they use. The key, of course, is, we can define that, but the value could be anything, and could be anything as complex as you like. One way that we can map this to RDDs, of course, is using a tuple. Okay, so that's a very useful kind of analogy in the Spark world, and this is how we can do the relevant mapping. So there's a couple of sort of approaches that we have available. Save pairs will do this for us directly. But if we find that we've got some data where we haven't actually defined a key, there's something called save values, which will help us and be able to generate some sort of unique affinity keys for us in order to help us with this kind of problem. Because, of course, not everything in life necessarily has a key associated with it, but in this case, we have something that can really help us. All right, then. So a couple of quick examples then. This is Scala Code, okay, but should be reasonably readable. So we've created a program at the top there called Spark Ignite Writer. We get our Spark context. We create our Ignite context based upon the Spark context, okay, and then point it to a configuration file. We then define this thing called shared RDD, okay, which is the actual cache that we're going to use, okay. Think of this as the wrapper around some Ignite cache that we're going to use. And then finally, we're actually doing some work. So the very last line of code there, we're actually writing some stuff in, that happens to be 100, it's a list from 1 to 100,000, 10 levels of parallelism there, and it's simply doing a map of that directly into Spark. Okay, so reading the stuff then, because it's a live view, we can read things back directly. There's nothing special that we need to do in terms of anything extra for loading or any of those capabilities. Remember, everything is supported. Whatever the RDD can do, Ignite can do as well. RDD methods are available for you to use straight away as well. Okay, so as soon as you created the data, how you want to manipulate it is very, very simple. There's nothing extra in terms of the work that you need to do to be able to access that data. And if we look at a simple example in terms of how we read the code then, so this is almost the same as what we had previously. Again, we just define sort of an application name. We get our Spark context. We get our Ignite context, pointing to the same configuration file that we previously used in this case. And again, we're using the shared RDD, okay, same name that we previously used for where we were writing this. And then here, we're just doing some filtering, okay? So we just that data that we previously wrote in, now we're just trying to pull some of it back out again. And in this case, we're just interested in the values that happen to be over 50,000. Okay, so great. So I've got 7 minutes or so. Okay, so let me switch. Fingers crossed that this is going to work. So I need to end this presentation, and let's just have a look at how the display is. Okay, so there's a few things there which we need to get rid of. Let's close this, and there we go. All right, now, let me just test this out. Does it zoom in? It does. That's great. That's fabulous. Okay, so at least I've done a little bit of prep work there. Okay, so I've got 4 terminal windows open. Okay, so we'll see how this goes. Because I'm terrible and I've got fat fingers, okay, I'm going to cheat. Okay, I'm terrible at typing, so I'm going to copy these commands. Otherwise, we'll be here all day, and you guys want to get home. So I don't want to stand between you and the next thing that you have scheduled for today. All right, so the first thing we're going to do, let me fire up a Spark instance, okay, Spark master, there we go. Okay, so this is just launching it, so I've got Spark installed on the laptop. I'm just going to start that up, okay, from the command line. That should come back very, very quickly, and we'll have a look at that from the web page as well. And let me just get a worker going as well. All right, so there we go. And again, let me just zoom in so that you can follow along and see that I'm not cheating or doing anything that, unusual. Okay, so yeah, just I happen to know that this machine is called MacBook Pro.local port 7077. Okay, and then just fire that up. It's not going to come back with any sort of information messages. I find them terribly distracting. So in this case, I've just told it, please don't put any messages out on the console. So trust me, it's working. Okay, so if we just go back here and we launch a browser, we can just double check. Let's have a look. Is it 7080 is the port I've got? Oh, no. That's mistyped. My apologies. I told you, I've got fat fingers. There we go. And I can't see. All right, there we go. So there's our Spark master, okay? And then if you look, there's one worker that's running as well on that local machine. There we go. So we know that that's up and running. Okay, no problems there. Okay. From another window here, what I'll do is I will launch an Ignite node. Okay, so again, let me zoom in here and just show you that I'm not doing anything unusual. Okay, so it's simply a startup script, ignite.sh. Okay, and then I'm passing it a configuration file that I'm going to use. Okay, that's the standard file that we kind of referenced in the slides. That's part of the distribution that you get with Ignite. You can have a look at that in your own time, and this will just launch a single node. Okay, that's all. It's sufficient for our needs. The thing with Ignite is that it will run pretty much anywhere, okay? It will run on a laptop, it will run in Kubernetes, it will run on Amazon Web Services, Azure, wherever you like. I mean, as long as you've set it up properly, these things will just find each other, the cluster will just, it'll just form. All right, so what that tells us is that we've got one server up and running, which is exactly what we want, that's fine. All right, and let me just move this across here. All right, so we've got Ignite running. Now, I've kind of packaged that reader and writer program. Remember that we had that a little bit earlier. And again, let me zoom in and then just show you I'm not cheating or doing anything unusual. It's just bundled up as a jar file, okay? So both my reader and writer, I've used Maven to build this small kind of jar file which contains both of these programs. I'm just going to call, in this case, the writer program, okay, to actually write something into this shared RDD cache. Okay, give that a moment or two. It might run a little bit slowly. Hopefully, it won't take too long. Okay, again, I'm conscious of time, so we've only got about 3 minutes. So again, console logging is disabled just for the interest of so we can see what's actually going on without all the intervening messages that are kind of running. If you're a little bit sharp-eyed, you'll see over here that there's been a little bit of activity on the Ignite side. So yeah, you can see some messages popping up there telling you what's going on. And here, for example, there it's finished, okay? So the prompt is returned. Nothing particularly interesting. You're probably underwhelmed, okay? You're thinking, well, okay, it's just written some data into the cache, that's all. And now, if we just read that back, using the other program, again, just using this from the command line. Okay, and let me, again, zoom in. So those of you who are a little bit sharp-eyed, you'll see that this time I'm just saying RDD reader, okay? So now all I want to do is just to get that data back out from Spark. Okay, so again, console logging not configured, and this takes a moment or two again. We should get back a result that says sort of 50,000 or something like that. I think that's there we go. So doing a little bit of work there. Okay, there we are. So the count is 50,000, okay? Nothing particularly amazing about that. What it is, we've got this shared kind of RDD cache now, okay? So we can write stuff in, we can get stuff out, okay? Very, very simple. Now, if I quickly just go back here, and assuming that I don't lose my Ignite node, because that's all I've got running at the moment, and it's not configured for persistence or anything like that, let me kill my Spark worker. Just do a Control-C there, and get rid of that. There we go. So that's gone, and let me shut down my Spark master cleanly. Oh, sorry. Right, things are running very sluggishly. I'm just wondering if how I'm doing on memory. Let's have a look. Well, it's 1.4 gig available, so that should be okay. So actually, we can probably not worry about stop master. That's what we want. Okay, so there we go. So we'll just ensure that our master is stopped cleanly. Okay, there we go. All right, now, that's fine, okay? So I did some work there. It's stored in Ignite at the moment, okay? My one node that's up and running. If I now go to the IDE, okay, and again, this is part of the distribution of code that you get if you download it from the Apache website. There is some Scala and Java code to actually show you how to read and write and get stuff in from Spark. This is some Scala code. What it does, it will use that same shared RDD name. It will read some data from there, and it will do some manipulation, and it will run some SQL, okay? So let me just run that. Okay, let me just blow that up for you a little bit so we can see what's going on. Okay, fair amount of error messages there. I didn't set that up to disable those. There we go. Okay, so it's done some arithmetic. Okay, so it's read that data in, done some arithmetic, some manipulation, and it's run some SQL code as well. Okay, to give you that sort of tabular output too. And you know, this is one very, very simple case of how we can use this kind of shared RDD to be able to share state amongst different Spark applications. Okay, so I am out of time. And fortunately for me, that finished reasonably well. Okay, so any further information that you need, I think you can, let me just see if we can go back here. Oh, I think we can just show the last slide as it is. Should be just fine. There we go. So ignite.apache.org is the place to go, okay? Again, you can download the binary distribution, you can download the code, you can build it yourself, you can poke around, have a look at these configuration files, the Scala and XML sort of configuration files. You can look at the Scala and Java examples, and I think watch this space, okay? So the data frame support is almost there. I think it's just being reviewed. That was something that we pushed out very, very soon. So you'll start to see that in the very near future. Okay, great. Okay, thank you, Ruben. Thank you. Oh, thank you very much.
Thanks a lot. Thank you also because you were very brave at running live demos. So my respect. Of course, do you have any question for Akmal? No? Yes, one over there. Could you please stand up and shout loud because otherwise we won't hear you? Akmal, can you please repeat the question?
Yes, so I think the gentleman was saying that they're using Kafka and PostgreSQL, if I'm correct. And basically, the question was asking, you know, given that Ignite offers sort of SQL capabilities and sort of persistence, you know, would it be a good idea to remove Postgres? My honest answer would be, I don't know. I think partly, again, it's your use case and your business case, what you're actually using Postgres for. And so if you're finding that Postgres meets those needs adequately today, then stick with it. You know, it's a very robust, very popular relational system, and it's extremely well supported. You know, fabulous community around it. I think in those cases, perhaps where you need that kind of memory boost and you're looking for distributed processing, you want to make the use of the cluster, Ignite, its caching capability, its ability to run distributed SQL, then there may be a good case that you could argue that might help you in that situation. But again, I think you need to understand how you're processing the data. If you find that things like co-location is something that could work well for you, and perhaps the ability just to cache data is something that could be useful for your use case, then definitely worth having a look at this. But my suggestion would be to you, for the persistence capability, Ignite offers a couple of options. So you could use its native persistence if you want, or you could plug into a third party. So if you're already using Postgres, you can still use Postgres, okay? You can use MySQL, you can use Oracle, DB2, anything you like. It'll work with IDFS as well, and it'll work with a lot of these NoSQL products too. So you've got a sort of wide range of choices there. But if it's, you want a bit more information, feel free to get in touch with me, okay? So it's just first name dot last name at gridgain.com. And I'd be very happy to take that offline and try and help you further with that.
Thank you.
You're welcome.